Good day, everyone. Today we are going to be treating calculability. In English, it's computability. It's a course, like it's a topic from a course that we call programmation functionelle. That's for those that are doing math informatique courses. It's a course we call programmation functionelle. That's OPM. Bien soit programmation fonctionnelle. So today we are going to be looking at the introduction into this topic, calculability, because it's mainly the first topic that is being treated, because in this particular topic it brings out the whole concept, as well as the whole idea about the function, recursivity, that's recursive functions, how to construct recursive functions, how to it's all about, I feel it's all about algorithm, because it's also a step-by-step process. So in this video we're going to be looking at the introduction to calculability. We're going to define it. We are going to treat recursive functions. We are going to define recursive functions. There's a term that we call arity. We're going to talk about the arity of functions. We'll talk about base functions, how to construct recursive functions, the notations that we get to use, the projections, as well as the likes. So we'll begin with, but before we start, I realized also that for me, maybe there might be more, but then I got to realize that we have three classes of programmation, like programming, three classes of programming languages. We have the one we're going to treat now, which is the functional language, where we get to treat functions, play around functions and the rest. And then we have the logic ones, as well as the object-oriented programming, for those that will major in computer science engineering. So let's begin. The introduction to calculability. Calculability, we can also call it recursivity, because we get to do recursive functions. It's also a branch in mathematics and informatics, the theoretical part of it. Like there is also the programming language part, which we call OCaml, where you get to program like mathematical, like the logic part of mathematics, and as well as some informatics, because you also find recursive functions, and you can also do recursive functions in C as well, C language. So it's more of math logic, but it's programming. That's the fun part about it. So calculability, it helps to calculate functions using algorithm. So in general, we define calculability as a function that can be calculated with the aid of an algorithm, because it follows a step-by-step process or instruction, like I said at the beginning of this video. So next we're going to look at is the recursive functions. Generally when we're defining functions, we define using the domain and the codomain. That's in French you say the point de départ, point d'arrivée, or même we also use domain and codomain of the function. So it's like the point de départ, point d'arrivée, where you're starting from and where it's leading you to. So we'll be concerned about the functions that are defined in. So I'm defining a function f. This is the domain, and this is the codomain. So basically you notice that it's natural numbers to natural numbers. We're starting from natural numbers, we're ending in natural numbers, so we don't have anything to do with maybe the real numbers, complex numbers. We are dealing with natural numbers. In French we say entier, so we're having entier, vers, and entier. So when we say n puissance p, that's n raised to the power of p, which is this. I'll just call this n. So if we have n raised to the power of p, we know it means n times n times n p times. That's basically what it means. N times n times n times n times n p times. That's n raised to the power of p. So that's why when you have n raised to the power of 3, you have n times n times n. That's 3 times. Raised to the power of 5, n times n times n times n times n 5 times. So n raised to the power of p is n times n times n times n times n p times. In French we say n4, p4. So p is also going to be found in n. So we are all talking about functions that are in n, natural numbers. So basically we said we are looking at the domain and the codomain when dealing with functions. But okay, so we have où or where in English. NP is called the domain of f, and n is called the codomain of f. En plus, n raised to the power of p, the functions we always associate them with variables. So same thing is going to apply here. So we have x1, x2, p fois, and we associate it with its function p fois. But now the question is, what is this p? Remember I said at the beginning of the video that we're going to talk about the arity, and that's exactly what the p is. P is the arity of the function f. In this case, it just means the number of arguments, or the number, or generally what we know, the number of variables. So p is called the arity of f, which is the number of variables. In this case we have arity p because we're having p variables. If it was n raised to the power of 3, our arity will be 3. N raised to the power of 4, our arity will be 4. That's how it works. So when we don't have, okay, now when we don't have we start from 1, 2, 3, 4. Now what if we don't have a variable? Generally when we don't have a variable, we have f but no variable, we always get a constant. So maybe we can note this. So we have f without a variable is a constant. And in calculability, in functions, any function that is, because in this case it doesn't have any it doesn't start from 1, 2, 3, it's at 0, so we say it's darité 0. In French it's called, okay, I should write that. In English it's called, in French it's called l'arité, or you can just remove this. In English it is arity, which we said is the number of arguments or variables that a function takes. So whenever we don't have that, it will give us a constant when we don't have it, because normally if I have if, let's say for example, if p is equal to 1, okay, yes. if p is equal to 1, we say f is of derivative 1. Derivative 1. So we have n puissance p vers n. So if p is equal to 1, it means f est derivative 1, and we call this monnaie. So that means we're having, if n is raised to the power of 1, we're having x1 vers f of x1. If n is equal to 2, if p is equal to 2, it means it's derivative 2. And if it's derivative 2, we call it binaire. Now, let me just do a petit rappel. If p is equal to 1, we say it's derivative 1 and we say it is monnaie. So it means it has only one variable. That's basically what it means. It has only one variable. Let's take, for example, I have, this is derivative 1, it has only one variable, so I'll say f of x. And I can define my f of x with, let me say, 3x. That's how it is. It has just one variable. But in the case of binaire, we're having two variables. Let's say x and y. Let's say we have 3xy. So that's how it is. So if p is equal to 3, it means it's of derivative 3, and then we have three variables. So if p is equal to 3, it means we have f of x1, x2, x3, or f of x, y, z, but it basically just means three variables. So if p is equal to 3, we have three variables, and then we call this tertiel, if I pronounced it well. Okay, it basically goes on like that up to, if p is equal to n, so it keeps going down. If p is equal to n, finally, it means the function is of arity n, because we'll be having n variables. Okay, and so we say f is n. So remember where we said I made a remark earlier that I said that functions that are of derivative 0 will give us constant. We'll be having constant. So that's to say the point de départ and the point de dérivée, we don't have variables, so constant at the end. So by convention, it is a recursive function. By convention, it is a recursive function. So in summary, we said arity is the number of arguments or variables that a function can take, and then a null function, which is this null function, this is what we call takes no arguments or variable. That's what it means. So basically, if I have f of that, I can have maybe equal to 2, equal to 3, and all. So now we said I said that it's a recursive function, but now what is a recursive function? Okay, I think my battery is very low now. I'll see you in the next video. Thank you. Just stay tuned.